We are live tonight. This is Standing for Truth coming to you. We've got Friday night discussions. I've got Raw Matt here. Snake was right. So we're just going to talk creation, evolution, the Bible, theism, atheism, other related topics. In the off air, we were kind of talking about health, longevity, which in a way does directly relate to the Bible itself. So Matt, being the expert in that, we were kind of going over a few things in regards to diet, vitamins, antioxidants, heavy metal toxicity. And then Taylor brought up, like breads and things like that. I was going to ask you, Matt, if you're going to go the bread route, what's the best bread to eat? Like, I know here in our household, my wife, she makes homemade sour bread or sourdough bread. Like, would that be, because I guess it gets all the good bacteria and apparently helps with your gut and everything. Like, what are your thoughts on that?
Well, I don't think that it's necessarily better just for that reason alone. It does something far, far better for you. Fermented bread, that is, like sourdough. It's the fact that fermentation actually removes more phytates than other processing methods. And because grains contain phytates, which have a tendency to leach minerals and nutrients, either from your body or from other foods, depending on how much you eat of it, we don't really want that. So, I mean, we want as much nutrients as we can get. And grains have a tendency to do that a lot. That's why the Egyptians had high amounts of arthritis and bone degenerative diseases, because their staples were grain. So usually when you get high amounts of populations, the only way to sustain high populations is through agriculture, and agriculture is farming with grains usually. So the higher the grain content, the higher it gets. I would personally actually rather people eat meat than grain, frankly, because grain has a really bad side effect on the body.
So it's like all this white bread and all that kind of stuff that you find in the grocery store. Wasn't it due to, I mean, shelf life wise? And I mean, the bread before is just going bad so fast, bad for business kind of thing.
Yeah.
And then once they actually put in, the chemicals to preserve it, I mean, doesn't that just take out all the necessary nutrients?
Yeah, well, here in the United States, you can find it. It actually says on the label, bleached white bread, or bleached, and then it says fortified
Wonder bread.
Because
that's terrible for you.
Yeah. Oh yeah. What do you think, Taylor? You think so too?
Yeah, that's why I was trying to kick breads. I mean, I'm getting back onto that, but yeah, I've heard sourdough, like homemade, like real good sourdough, like we get from the farmer's market. That's good for you, as good as bread can get. But
well, because it seems like these days, based on the lack of vitamins and nutrients that you're getting from all the various foods, the food groups in general, there's such a lack of it based on just the way the world is right now. But what is that why we have to supplement a little bit more these days, Matt, than say maybe in the past, when the actual foods and fruits and vegetables were actually giving us the necessary nutrients? Like you were talking about, even vegetables these days, kale, cruciferous vegetables and stuff, like even they might have chemicals and heavy metals attached to them. So it's almost like you can't even have certain vegetables without getting a little bit of poison and toxins with it.
Yeah, there's definitely a side effect and consequence to eating a lot of what are called healthy foods nowadays too. But let's go back one step and actually talk about what you just mentioned, is the fact that most of our foods that are grown are actually don't contain a lot that they used to because of topsoil erosion. We what is that? We constantly are farming our ground. We don't give it any rest, and so our foods are leaching the soil out continuously. Like, you ever heard of the Dust Bowl that was in the United States? They leached everything out of the soil by farming and planting everything. And in Israel, they let the land rest every year, after every 7. So it gets a chance to replenish those minerals that are in the soil. We don't do that. We constantly are farming. And then they realize that NPK is the only nutrients that they need for a lot of things to actually just grow. So they got real lazy and are like, well, that's all that a tomato needs to grow. So let's just give it those basic nutrients. So there was actually a guy that lived in Vegas for a while, and he decided, I want to live off tomatoes. Well, after about 6 months, I think he died. He didn't last too long. His body was so mineral deficient. It lacked so many things that he couldn't even do it. So those are the kind of foods that we've got. They're picked early. They sit on a grocery store shelf for God knows how long. They're grown in soil that's depleted. And the same thing happens to the animals that we're eating as well. You know, you eat cattle. Well, the cattle are being fed worthless corn and grain as well. They're not walking around eating grass like they should.
Yeah,
So,
only buy grass-fed. I only do grass-fed milk because you
nice.
get the same lipids as they do.
Oh yeah, oh yeah. They've actually done the studies on the milk that comes out of grass-fed cattle is full of what's called GLA, and it's just really really good types of fat that's not in when these cattle eat all the grain and corn. But
Yeah.
it's a cheap supplement for the government. Here they subsidize corn and grain, so it's a super cheap element. They mostly make the corn for #2 high fructose corn syrup, so it's dirt cheap.
Well, then what about all like the genetically modified foods, the genetically modified organisms and stuff? You know, are these also depleted of the necessary vitamins and minerals and nutrients?
That's really, it's not necessarily if it's genetically modified or hybridized, that really doesn't matter. It's kind of where it's grown and how it's grown. Like Hawaii, for example, is a volcanic ash, right? So you get high mineralized fruit when you go there. But that's why it tastes better. People pay more for it. But when you're getting into your own backyard and you've been growing something for a really long time in the same soil over and over, you kind of have to turn it over a little bit, right? That's why people add things so much to their soils all the time, because the things that you're growing leach all those minerals out. It's the plant's job to do that. So
it's kind of like a ripple effect. So if you're consuming the meat and then let's say the cow or you know, the chickens or whatever, if they're eating stuff that's toxic too, and they're being injected with, you know, hormones, growth hormones and antibiotics and all this kind of stuff, I mean, that's getting into the animal and then that's getting into us. But then the vegetables and fruits themselves are depleted. So now you're not getting the nutrients there. It's kind of just like one big ripple effect.
yeah, it's too bad, really, because we're doing things now to our foods that we've never done. So the side effects are kind of like obscure. We don't really know. Like they're mixing flounder fish with tomatoes to make them cold resistant, and the venom of snakes with corn to make them pest resistant. And I mean, that's all fine and dandy because, hey, it's better to eat those foods than to starve to death. Don't get me wrong. But the side effects, we have no idea what that's going to do to the body later. So kind of catch-22 on that.
Yeah, I think that it's a interesting point you brought up about vegetables because like they're hard to digest and they're bitter and stuff. Whereas like fruits actually want you to eat them. Like they're designed to be eaten. I mean, not designed in the way you think, but
Oh, I thought you converted.
yeah. But I wanted to ask you, what kind of fruits do you eat? Because like I can never get full on them for long.
Oh, here's your trick, my friend. Check this out. If you eat blueberries, you're going to be hungry in 2 hours. There's no doubt. So
Yeah.
These are the ones that I like. My favorite, my go-to is coconut. Coconut is incredible. I love it. It's high calorie. You get full. You actually struggle eating an entire coconut. I don't mean those Thai young coconuts with that really soft meat that you can scoop out with a spoon. Those are good for like a snack. But I'm talking about the mature coconuts with the really thick, hard meat. Those are really good. And then let's say that you want something more sweet. Well, usually I just go to kind of some berries for those because they're really rich and they contain a lot. So your body gets satiated really, really quickly because it's dependent on nutrients, not just empty calories. So your body's kind of like, wow, I like wild ones. I like wild mulberries. And another great way is to dehydrate them. If you dehydrate mango or papaya and you make like these little beef jerky sticks out of them, they taste really good and they fill you up for a long time. Like today, all I've had is actually mango, and I just ate a bunch of dehydrated mango. Worked great. Another one you might like is avocado. They make a good fake meat substitute, so you can slam them inside of a taco shell of anything, really, you know, cabbage, and then put on your dressing, whatever it may be, and make your taco meat be avocado. That's a really good one. It seems to me that the fats really are what fill you up, and coconut and avocado are really fatty. Another great one is durian. Now, I'm going to warn you and everybody else listening, durian is, you ever heard of Anthony Bourdain? He's the guy that travels and eats all the food.
Yeah, he just hung himself.
He hung himself. Well, that's horrible.
Oh, you just heard of this?
Yeah, I heard of that about a while ago. That happened.
Wow.
Yeah, and the interesting part for me is he had just been tweeting some like really bad stuff about Hillary Clinton, that he was like, I talked to her and like found out some stuff or something
No.
like that. And he was tweeting all that, and then he hung himself a couple days later.
Wow. Well, did he?
Yeah, I remember that. And that was after the election, though, right? Like, wasn't that in the last few years?
Yeah, that was just last summer, I think.
Yeah.
Something like that.
Yeah, that's crazy.
Whoa.
So then, Matt, when you talk about like the healthy fats, obviously, yeah, you get it from avocado. Avocado is huge. You get it from, I mean, just omega-369 oils or coconuts, huge as well. If you're depleted of all these vitamins and your diet's just not the way that it should be, and even if you are eating some of these, non-organic, chemical filled, whether it's fruits, vegetables, and you're just not feeling good and you have all these negative symptoms, and say you go to the doctors and they just treat you with, say, chemicals, whatever pill it might be, which then we know comes with a whole slew of side effects, that then you need another pill for that, and so on and so forth. Is that the best way to go about it? Or isn't it if it's just strictly diet, shouldn't we be looking to something natural, something from the earth to counterbalance those negative symptoms?
It would be great. It just depends really on the toxicity level that you're at. For example, fixing yourself naturally off stage 3 cancer might be impossible. Stage 3 and 4 get really, really hard. So if you've let something get so far unnaturally out of hand, using something naturally get it back might be tough. But for the most part, yeah, I recommend that. Toxicity builds up in a lot of different ways. That's why I recommended people take activated charcoal all the time, because it can do nothing but extend your life in every experiment that's ever been done. If you go to the PubMed research studies, I've done this, you can find it in my book and take all the links. They've tried to actually kill animals with it, and they put 50% of their diet with charcoal just to see what negative effects could come. The lowest, the most harmful thing that it did is to cattle, and it made them live 35% longer. Everything lived longer.
Wow.
So
what are they saying causes cancer from like grilling meat? I thought that was the charcoal from the charred meat.
Yeah, that's glycation though. But what happens is that's not actually from the charcoal. That's actually from the flame hitting the meat without water surrounding it. So what happens is the proteins and fats cross-link and cause a carcinogenic substance, because your body doesn't recognize these new proteins that have formed. So they're what's called advanced glycotic end products. And this advanced glycation is what causes the cancers to form. That's why meat is considered a class 1 carcinogen, because it's the processing methods of how we cook the meat. If you would actually boil meat underwater, you would never form any of those carcinogens to form. It's just a processing method, really.
Yeah, because, I mean, I trust you on that one. I love grilling meat, but I know I've definitely seen multiple things that says it's not too great for cancer.
No. Grilling, it's one of the most flavorful because you keep the vitamins in it. When you put meat in water and boil it, guess what? You've lost all those water-soluble vitamins because the water was solvent, right? Sucked them into it. So you've lost them now. So that's why the meat has no flavor. So if you're going to grill it, they've actually found that, you're going to find this funny, fast food restaurants have the least amount of glycotic, or AGE, the acronym, AGE is advanced glycotic end products in them than most meats, because they're processing things real fast, quickly, because they have to for all the service, all the people coming through it. So their meats are actually less cancer causing than when people go home and they slow roast them over a grill. So it's actually, the faster you can heat something up when it comes to meat, the healthier it is. And
then Matt, I remember in your debate with Nick Suter, I think his name was, he's actually the one that brought it up. If my memory serves me right, I think it was lobsters that lived to like almost 1,000 years or something. And a lot of it was due to a specific antioxidant that they had higher levels of. Can you elaborate on that a bit?
Yeah, sure. Actually, they don't know how long lobsters can live because every time they find one that old, they're killing it to eat it. So we don't know actually how long they can live. The last one they found was 500 years old in New York in the early 1900s, and it was huge. I think hundreds and hundreds of pounds. Well, they all barbecued it up and ate it. So that was pretty much the end of that one. Yeah, they produce a lot of a metabolic enzyme called superoxide dismutase, and they produce almost an unlimited amount. So that's pretty fascinating because that's pretty correlated to how long we're going to live. And we produce about 80 micrograms per deciliter per day, about on average. And it goes down after the age of about 27. It kind of starts to peak and go downhill. So we want to keep it at that 80. But what happens is every decade it goes down about 5 to 10%, more and more and more.
What makes it go down?
Great. We run out of this metabolic enzyme potential from a lot of factors. A lot of people burn out of it because they overwork themselves, they overtrain, they're stressed out. Stress is one of the main mediating factors of it. It could be bad diet. It's one of those things that's correlated with aging. Have you ever heard of Werner syndrome or progeria? They're aging diseases.
Yes.
And so when we study them, we want to find out, why are these little kids 11 and 12 years old as extremely aged? Well, there's two reasons. Their liver isn't producing this metabolic enzyme, superoxide dismutase, and they have very, very short telomeres. So those two factors are extremely important. Matter of fact, when they genetically alter mice and flies to have less superoxide dismutase, they live less of their life. So we know that we have to keep our liver strong. So the stronger your liver, the longer you're going to live.
So is there a way to increase those levels?
There is. Matter of fact, yeah, there's a few ways I can tell you guys now.
Yeah, go ahead.
Well, I don't want you guys to go to the store and just buy superoxide dismutase and glutathione peroxidase and glutathione reductase and catalase. These things are enteric coated, and they're like a steroid. They're like injecting a hormone into your body. Your body says now, oh, good, I don't naturally need to produce this anymore. So the same thing goes with these metabolic enzymes. Don't buy them. Make your body produce them. So here's the herbs to do that. One of my favorite ones is called jogulin or gynostemma. And that's a natural herb that naturally produces superoxide dismutase at a very, very high end. That's one of the highest producers of it. Another really good one would be hawthorn berry. That tastes a little better. It actually has a little sour taste to it. That's a great one. Another one is sea buckthorn berry. It's more expensive because it's sold for a rare omega fat that's called omega-7. And then one of my personal favorites is Lycium barbarum or goji berry. That's a great one. A little bit more expensive now that it's more popular, but all of these increase superoxide dismutase levels. So again, I use the herbs because they contain sesquiterpenes, which means that they are a precursor to having your body make these things. So it's really good. And goji does more than just that. It also increases human growth hormone. So thumbs up on that for everybody listening.
Do we have specific genes that are correlated or related to longevity?
Absolutely. We have 4 of the FOXO genes. Those are directly correlated with how long we're going to live. We have the sirtuins. We have 7 of those. All of them are correlated to how long you're going to live. We have a lot of genes that are correlated with longevity. Those are your more popular ones because they're regulated to a gene switch called mTOR. So you switch that sucker off and those genes turn on. That's why polyphasic eating is usually really important for longevity, because the fact that they control epigenetically, they switch on and off those longevity genes. That's why when people go into starvation mode, the body goes, uh-oh, I need to protect myself for famine. So it turns on these genes so you live longer. That's why it's proven that caloric restriction is one of the things that makes people live longer.
Wow. So like if we get into, say, the creation model now, and then obviously Snake here can give his views on it. If we know that, these genes associated with, say, aging and lifespan, if they were affected, say, as a result of the fall, either, directly through mutations or maybe just indirectly through genetic bottlenecks, maybe after the flood, does that make sense of what we know about the turning on and off of these specific genes that we know today? The reason why especially according to the Bible, why our maximum age has decreased. I mean, obviously we know that the average lifespan seems to have increased due to medical intervention, but the maximum lifespan doesn't seem to have increased. Does that have a correlation there?
Well, I think so, but I've talked long enough, so I'll let Snake jump in, and then I'll give. I think the MTHFR gene is correlated to why we're also losing more functions of genes. But go ahead, Snake, if you want to answer that too.
I mean, I think it's really interesting research, and I hope it goes much further. But as far as what I would critique about, the biblical model is like, I mean, like you can make it fit, but I think that's all you can do is just make it fit. There's no direct evidence. So
would you agree that, I mean, I think evolutionists that I've talked to, I mean, they're in and around. I mean, I've even had some say that it was closer to 150 new mutations per person per generation, but I think it's safe to say about 60 to 100 per person per generation. Like, do you believe with that data point there, Snake?
that's pretty much in line with what I've read.
And then that would be within the reproductive line, right? Like, I think, isn't it like every cell division, it's 3 new mutations accumulate in the somatic lines?
Well, I think that's per human generation.
Right.
Like your individual cells, they do mutate, and then that's when they basically are programmed to die. Your body's pretty good at sensing which cells need to die, and while you're in development, you're not going to have a likely chance of one of your cells mutating in those few divisions. So the human rate is per baby. The bacterial rate is per cell.
Right. So technically, if we're accumulating, say, roughly 100 new mutations per person per generation, how come that doesn't logically follow? And this also goes with everything we were talking about in regards to, nutrition, diet, antioxidant, these genes that are directly related to longevity. If we actually put mutations in there as well, if you're more mutated today than you were yesterday, and you're more mutated than, say, your grandparents and then their grandparents, with that accumulation of mutations, can't we extrapolate that to, say, a point of least genetic mutation accumulation, say at least a point of least genetic entropy? Not only is that consistent, but doesn't that just logically follow? Isn't that just a logical extrapolation based on the data?
The extrapolation being at the point of least genetic entropy that people would live longer.
Right, and not just that, also all the other factors that we discussed before, right? If we have a far superior environment, if the food is more superior, whether it's the vegetables, the nutrients, and the specific genes that are directly correlated to longevity and the mutation accumulation, doesn't that would that not logically follow according to, I guess, your worldview?
Well, sure. Under those circumstances, that would certainly follow, I would think.
So if we have a biblical starting point, and that's what we read about in say Genesis, and after the fall we see that everything has been corrupted, we see decay, extinction, for one. Is that not convincing to you that maybe man did live? And even if we look to legends, right? I mean, there's hundreds and hundreds of legends of the golden age where people live to 8, 9, 1,000 years old. Usually, a multitude of legends usually have and come from a common source. right? So I mean, all these different lines of evidence, because it's not just one line of evidence, mutation accumulation, it's diet, it's environment, it's mutation accumulation. Isn't it the equation, you know, genetics plus environment, so G plus E equals phenotype? So all these things considered, is that not compelling to you, or compelling evidence to you that, hey, maybe, you know, maybe the Genesis account of history has some validity to it?
Well, I mean, I think your conclusion is valid within those premises, but like, I don't think you can establish the premise of the Bible.
Well, isn't it the Bible that has a recorded history of, like Matt, if you want to jump in here, when you were talking with Nick Suter in your debate, I think your question was all these things considered, and with, I think it might have been the turning on of these longevity genes, you know, is it possible, hypothetically, that we could live once again to these extremely long lives? And he, I believe he agreed. He said, yes, it's a possibility. Can you elaborate on that, Matt?
Yeah, he kind of did. I wish we would have got more into a couple other things, because I wanted to show him that there's an actual study that we can see that what happened, and it was called the Pottinger cat study. And what they did is they took these cats that were big cats, not house cats, and they put them in a zoo. And of course, giving cats food is hard, because fresh food is hard to always obtain and give to large cats. They need large amounts of it. So what they did is they said, okay, maybe we're just going to start preparing all the cats' foods. We're just going to start cooking everything like people do. And then we can save it and preserve it, because cooked food lasts longer than fresh food. But what happened is, after about 3 to 4 generations, the mutation load was so bad in them from feeding these cats these new types of food, that there was a huge problem. And they started having children that were all messed up. Their own genetics were messed up. After about 4 more generations, they were actually all mutated up. They not that they were being born all deformed, but they had less fitness, less health. They had diseases. They had cancer. So since that time, it's been illegal at all zoos in the United States that it's illegal to feed cats cooked food. So if our natural diet was to be like in the Garden of Eden and to consume these foods naturally off the trees and the plants, then the advent of cooking and traveling and migrating and changing our food and altering it because of migration and being lazy and making foods taste better, we wanted to eat things that we weren't naturally designed to eat. So it dramatically affected us, just like it affected those cats. And we have a gene inside of us called the MTHFR gene, and it's directly correlated with how well other genes function and how good they do. And that gene is mutated in every single human being alive, everywhere from 20 to 70% less function. And because that gene controls all other genes, the worse it gets, the worse other genes get. So we have people walking around that have 70% less functioning of methylation, which is a detoxification capacity of your body, than we normally have had. So we're seeing a compounding problem with disease and gene loss and gene problems continuously. And of course, it's going to be extrapolated more now because we have more chemicals and pollution and toxins, but people have always pretty much eaten bad. So I like to go backwards in time and see if it logically melds with our model, and it just does. Of course, you know, we could be on crack as well and be thinking of making something out of nothing. But I don't know. There's a lot of correlations that I see, so that's what I'm going with. Oh, he's muted. He might be gone. Taylor, you can jump in.
Yeah, I mean, I was just going to say on the topic of mutation accumulation, I mean, I think, you know, within every model, you're going to have things that are going to fit. Like, you know, you can say the sun comes up in our model, and obviously that's a lot of models are going to predict that. But just because you can make things, just because the logic that you follow is valid, it doesn't mean that the premises are valid. But I mean, I think you get that. But as far as how we account for mutation, slightly deleterious mutation accumulation, there's basically like 5 points about that, and one is just basic recombination, where you shuffle the genes around. That's during reproduction, and obviously you get new combinations, and some of the children are going to just by luck get all the good genes, and some by bad luck are going to get all the bad genes, and so it kind of almost restarts, at least in some genes, in that way, because those genes can now be spread on. And most of the time, the genes are copied perfectly. So the healthy genes are going to most likely stay in the population unless they're very closely associated with some other beneficial mutation. Then it won't accumulate as many. And then there's like most out of the hundreds of mutations, about 40 to 70% have been calculated to be deleterious. In some fashion, like from severely to just slightly deleterious. And then the rest of those are beneficial and compensatory. But as we know, like the beneficial mutations, they can't account for stopping mutation accumulation. They can't offset that just by themselves. So there's also compensatory mutations, which also help, and depending on the context, they can be counted as beneficial mutations or not. And basically, what compensatory mutations is, they essentially, if a system takes a hit, it will make the system better, and that's just by chance. But some of these mutations will make other processes work better, either like with a direct mutation to that gene that makes it more stable, or some indirect chemical process that makes it work more smoothly. And then there's various forms of epistasis, which I think we might want to get into, because I think your rebuttal is basically that epistasis makes the problem worse. But you guys think that, I've heard this argument a lot, that the slightly deleterious mutations.
I'm just going to jump in there, because you brought up, many different points and topics, which is good. That's good. Maybe we'll start, right at the beginning, and then we'll jump into synergistic epistasis, maybe as a final point. So technically,
could I finish my thought real quick?
Well, but then the thing is, it's just going to be diluted down with the other 5 things you just mentioned. Like, why don't we go into, compensatory mutations, beneficial mutations? How many mutations? You said it's 40 to 70% that are deleterious. Did you say that? Because I wanted to touch on that.
Yeah, and I was just going to clarify. You guys believe that they accumulate because they're less visible to selection, right?
Well, because if they have such a trivial effect on fitness, well, at the end of the day, they're going to be, I'd call them near neutral, but natural selection is not going to be able to see them. And then based on the fact that we accumulate, say, 60 to 100 new mutations per person per generation, that high mutation rate, I would say, is a profound problem for, evolutionary theory. So the fact that, these harmful mutations only have a tiny effect on fitness, and then that means that, those harmful mutations there that are just nearly neutral, they're not detrimental enough for natural selection to rid the population of them, but they're deleterious enough to still build up and be invisible to natural selection. So that seems that the human genome must be accumulating harmful mutations continuously, and then that the genomes would slowly rust out. But you said that the amount of those mutations, so the 60 to 100, are you saying 40 to 70% of those are deleterious? Or how many of those 60 to 100 do you believe are deleterious versus, say, just completely neutral, no effect at all on fitness?
Well, in the study, an upper limit on the functional fraction of the human genome,
Right.
They found that approximately 24% of all mutations occurring in the coding regions are synonymous. So it literally just doesn't change anything. It's completely silent. Has no effect at all.
If there's like a mutation in the 3rd position codon. Like there'd be, so it would be, you're saying it's completely neutral, but what if those, say, third positions do have, are you saying
I
that
mean, it actually creates, because for some amino acids they have multiple codon sets that code for them.
yeah, like they're redundant?
Yeah.
Yeah, but the thing is, if redundancy is important to the genome as a whole, if there is a mutation there, and then say another gene kind of takes over for that specific gene, I mean, it's still gonna have, like, I see no way that a mutation can be absolutely neutral. Yes, neutral to the, to the phenotype, but I see in no way that any mutation can be absolutely 100% neutral to the genotype, right? It must have at least a tiny effect. But I think we don't have unlimited, well, I just want to make this point. We don't have unlimited sensitivity, in these tests. So there's probably no way to actually know for sure if there are any neutral mutations. The genome is so big, there's so much going on, it's multidimensional. How can you know for certain if a mutation really is absolutely neutral?
Well, for example, there's a asparagine codes for GAU and GAC. So one codon change, no change in amino acid.
Right, but without unlimited
aspartate.
Right, but without unlimited sensitivity in testing, how can you still determine conclusively that this is a neutral mutation that has absolutely no effect on fitness?
Because but I think it codes for the same amino acid. So one letter difference will code for the same amino acid, which makes the literally exactly the same protein to the atomic level.
Right. And this redundancy, these redundant elements, they're used to slow and speed processes in the cell. So at the end of the day, what might seem neutral to, say, the perspective of the organism's physical fitness, the phenotype, I don't believe that it can be demonstrated that it's absolutely neutral to the perspective or to the genotype overall. But
it is. If a single letter change doesn't change the actual protein, how does that have an effect on the organism?
Well, if I have a book the size of an encyclopedia and I have one single spelling mistake, it's going to be seemingly neutral to the perspective of the book as a whole. But that single spelling mistake, anybody is going to agree, is somewhat deleterious. You're not going to notice an effect until obviously the accumulation of them over time, right? It's destructive. But
do you know what a silent mutation is?
What's that?
Are you familiar with silent mutations?
Yes.
So that's basically what it is. So a protein is made out of amino acids, and the sequence of amino acids is what creates the identity of the protein. So if the mutation does not change the sequence of amino acids, that mutation has no effect.
But are you saying that this redundancy, say in the cell, in the genome, are you saying that it's not important overall to the organism itself? I mean, I just told you, I mean, there are roles that this redundancy plays. I mean, in computer code, for example, redundancy we look at as beneficial, effective, right? But you're saying to the genome, this redundancy, or say a mutation, a silent mutation, it's just absolutely neutral, right? I don't believe that, because we don't have unlimited sensitivity to tell for sure if a mutation such as that really is absolutely neutral. But let's say, for sake of argument, that it is, okay? You said 40 to 70% of these mutations are deleterious, the 60 to 100 per person per generation. Is that what you're saying?
Yeah, and then out of the same study, it says the empirical mean estimate for the deleterious mutation rate accounts for approximately 40% of the total mutation rate.
Right. So here, let me, I think I actually have that paper right here. So that data is based on how much percentage in functionality of the human genome. Oh, here it is. So
yeah,
what I have here, it is being shown that if a substantial fraction of the human genome is functional, right? AKA is not junk DNA. Then the evolution of man would not be possible due to genetic degeneration. So in this paper, the author states that human evolution would be very problematic if the genome was 10% functional, but would be completely impossible if 25% or more was functional. Therefore, is that what you're basing the percentage of deleterious versus neutral mutations on?
Well, they were just measuring how many mutations occur in the coding regions of the DNA.
Right. But
because the reason most of them are silent is because they occur in the non-coding regions of DNA.
Right.
So that has no effect. Like it doesn't even matter what it is.
I know that's your philosophy and your belief, but the thing is, more than 10% of the genome is functional based on the evidence that we have and we know. Now, he says that human evolution would be impossible if 25% or more was functional. How much of the genome do you believe, percentage-wise, is functional?
Well, the science in this paper, it says about 15 to 20%, I believe.
Right. Now, since there's an evolutionary bias to this paper, and he's literally admitting that if more than 10% is just wait, I'm not done. Just more than 10% is functional, that's going to be very problematic for human evolution. But if more than 25% of the genome is functional, that makes human evolution impossible. Therefore, is he really going to conclude, based on the data, based on the evidence, that more than 25% of the genome is functional? I mean, does that make any sense that he would actually conclude that and come right out and admit that?
Well, the non-coding regions of DNA were not discovered through any process of evolution. It's literally, we just see that these regions are not used by the organism.
So we know that the non-coding DNA, those regions, they function much like a computer, right? They're involved in what? Regulatory functions, which to the audience, for their sake, that just means when and how fast to make specific proteins, which is important, obviously. Embryonic.
Yeah, DNA itself has like several functions.
Right. I'm talking about the non-coding areas that you're talking about, because you're saying they're looking at the non-protein coding regions. So they're also involved in, the timings of protein manufacture, the staging of proteins for construction of molecular machines, switches, for example. I mean, I can go on and on and on and on. Now, when we look at the ENCODE, which I know we have talked about, and someone like yourself would probably look to spurious transcription, and that's fine. But ENCODE did find that at least, and I'm saying at least 80% of the non-coding DNA was actively transcribed into RNA, which suggests function, right? So that's why we're saying and making the prediction that based on this trajectory of discovery, it seems to at least favor genome-wide functionality. That's why with, say, further, let's say, comprehensive knockout experiments, okay, say on humans, for example, or just mammals in general, there have been some, but not comprehensive tests. I would say that it's premature, for one, to make the absolute claim that the majority of non-coding DNA is non-functional. And I think based on what we know thus far, the trajectory of discovery favors genome-wide functionality. I think it's obvious it's more than 25%. How much more than 25%? Well, we'll see if our, prediction comes true with further research and data. But I mean, I think it's obviously more than 25% functional. What does that say about human evolution?
Well, we know that at least some genes don't have any function, or are at least not used for their functions in an organism. They're turned off through regulation, but that doesn't mean that they have no function themselves as DNAs and RNAs, but that doesn't necessarily mean they get translated into protein. So ENCODE has not actually found anything that significant. It hasn't proven that they get encoded into protein. So, well, and that's the evolutionary definition of the function.
Are you saying that for a gene to be functional, it has to be translated into a protein? I mean, obviously, there's other things going on in the genome as a whole. It's kind of like a play. If you look at a play, you got all the actors, the actresses on stage doing what they're doing. Okay, let's say the coding regions, for example. But behind stage, you got all these set directors, you got all these other workers that are working to make sure that the actors, the actresses, everybody on set is doing their job. they're equally functional. They're all equally in functional roles. So by you saying that if it's not protein coding, I mean, are you saying that roles in regulatory functions, embryonic development, the timings of protein manufacture, I mean, are you saying these aren't important functional roles? And if there's a mutation in a gene sequence such as this, are you saying that it's still absolutely neutral because it doesn't code for a protein? I mean, I don't really understand your logic there.
Well, if it doesn't encode for protein, it's just going to be used for regulatory function.
Yeah, so a regulatory function.
So the sequence doesn't really do anything.
So a regulatory function or a regulatory element is in charge of, you know, how fast, when, for example, to make specific proteins. I mean, that's pretty important. You can look at the phenomenon known as protein moonlighting. I mean, we got these proteins that are doing so many different things. RNA, the literature, you know, back in the day, what is it, the 70s, 60s, 70s, it was known as what, one protein, one gene, one function. So much has been overturned. I mean, the literature on RNA function alone is unimaginable. You know, RNA is doing unimaginable things. So for you to just hold on to your evolutionary philosophy in order to not admit the obvious fact that more than 25% of our genome is functional, and then ENCODE is telling us that over 80% is actively transcribed, what it's all doing, well, it's going to take further research, as I've said, but at least more than 25%, or at least 25% is functional. But you can't actually admit that because it makes deleterious mutation accumulation that much worse for you, and it makes human evolution pretty well impossible. So that's why you have to have this these types of rescue devices, these types of counter arguments that are actually just to defend and secure your evolutionary philosophy. I mean, that's what I'm personally hearing. Go ahead, Snake.
No, it's just that they haven't actually proven any functions for these genes. So.
Hey, emoji. Emo.
G, come
Hey,
in.
what's up, man?
Hey, what's up?
Hey, you all good?
Yeah, SFT, do you want to repeat that again for Mikey?
No, actually, I was listening for a while. I was just muted. That's
Okay.
all. Yeah.
Okay. Do you want to take this one?
Well, with respect to junk DNA, the thing is, the junk DNA doesn't actually mean function less. It just means it doesn't code for protein. It's just a fancy name they gave it, but junk doesn't necessarily mean useless, because you can use junk.
Okay, so I'm going to jump in there then. If we have, I had to run upstairs real quick, but I imagine I didn't miss much. So Richard Dawkins, for example, and yes, I'm going to use a quote here. You can look it up. In 2009, what he said, it is a remarkable fact that the greater part, okay, 95% in the case of humans, of the genome might as well not be there for all the difference it makes. Now, okay, after Dawkins realized that junk DNA is dead, and yes, they didn't say it's completely functionless. They said there would be some function found in it, but not nearly as much that has been discovered, okay? That's why people and scientists have been so dramatic and defensive with ENCODE. Okay, so he said, it was in a debate, I think it was Jonathan Sachs, Dawkins stated, I know there are some creationists who have jumped on it because they think it is awkward for Darwinism. Quite to the contrary, of course, it is exactly what a Darwinist would hope for, to find usefulness in a living world. So somebody like Dawkins is admitting that the greater part of the genome, 95%, is junk, may as well not be there. Wow, may as well not be there. Well, that rules out regulatory functions, timing of protein manufacturers, embryonic development. I mean, that needs to be there, of course. But now he's adjusting his position. So are you, emotionally stunted emoticon, actually going to tell me that this was not a surprise to anybody who knows what evolutionists used to believe? Go ahead.
Okay. So first, I'll just get it off the bat that whatever Dawkins says is not sacrosanct. It's not it is open to
I agree.
correction. Okay.
I agree. But he's a pretty famous and well-respected evolutionist. We got to agree with that.
He is. In fact, he is. But he's more of a science communicator. He does more of that instead of actual, writing literature for the.
He did write the book, The Greatest Show on Earth, and the Selfish Gene, though, right? And do you agree?
Right,
with,
he did write that.
Well, I want to get this out of the way. Do you agree with the quote that he said in 2009 in his book, that the remarkable fact is that the greater part of the genome might as well not be there? Do you agree with that statement? Let's pretend it wasn't Dawkins. Let's just say it was some random Joe Schmo, whether creationist or evolutionist. He made that claim. What would your response be? Go ahead, brother.
Okay, so but now knowing now that in fact some of the junk DNA have function, I would not agree with that statement. Although it could be removed, and some of it could be removed, and the organism would, the organism won't die. But it doesn't mean that it's not, just because it's not specifically needed, doesn't mean it doesn't have function.
What types of function does the non-coding regions of our DNA have? Like I named a few, right? You're listening: embryonic development, regulatory functions, stagings of proteins for construction, for the list goes on. Like what types of functions, what types of roles do you know of emotionally stunted emoticon?
Right. So again, the timing and the expression and so on, all that can be attributed to some of the non-coding DNA.
But aren't they?
Or the junk DNA.
Now, so they're active. They're creating RNA, but they're not coding for protein. Yes. So I know that's technically what junk DNA means, right? They're not coding for protein. But if it's, for one, active in those types of roles, and that it's also active in, correct me if I'm wrong, isn't it active in pervasive alternate splicing, cell differentiation? I think it's even in the non-coding regions that it was found to be active in X chromosome inactivation in women. Am I correct me if I'm wrong on that one?
So I'm not aware of all the functions, but I know that there is a lot of function to be found within junk DNA. But again, junk DNA was never meant to be functionless DNA.
I know. I don't want you to straw man, but I know that. But as I showed and demonstrated with Richard Dawkins, they did believe that roughly 95% of it may as well not be there. And you just admitted that you would not agree with that statement, which means you would not agree with Richard Dawkins. And Richard Dawkins didn't just pull that out of thin air. That was a leading thought back before ENCODE and, the accumulating papers and data that we've now discovered. So junk DNA paradigm's been overturned. We know it was profoundly wrong. It's being used in all sorts of ways. So
it's just a difference of how we use the word.
I'm going to let you guys go as long as you can. I need to ask emotionally stunted emoticon a question. If you have a mutation in the non-coding regions of DNA, and we know the non-coding regions of DNA function in, I'm not going to name them all again, but we can go on for probably an hour. Is that going to be deleterious, detrimental, harmful to that, to the genome?
Well, again, it depends. Not all mutations are deleterious. You can get a benefit. It could be deleterious. It could be fairly neutral.
But so in an area, I don't think you're answering the question. That's the problem. In an area that has roles in, cell differentiation, let's say intronic elements, roles involved in, alternate splicing, regulatory roles, embryonic development. These are important function and important roles. So if you have a mutation in the non-coding regions of DNA, which we know perform those very important roles, is it neutral? Is it deleterious? Is it detrimental to the point where natural selection is now going to rid the population of this mutant? Go ahead, answer the question.
Right. Again, it could be either one of the three. It could be neutral or well, relatively neutral, deleterious, or beneficial.
Would you say near neutral? Would you say near neutral? Like, let's say if it just has a very, very trivial effect on fitness, just tiny, you know, not noticeable to the phenotype. Natural selection isn't going to see it. Natural selection isn't going to rid the population of the mutant because it's not detrimental. You know, it's not detrimental enough where natural selection notices the mutant. But it seems like you had averted to the fact that it might be near neutral, right? It might have a small effect on fitness where it remains. Natural selection doesn't act upon it, but it remains. It doesn't have an effect overall on the phenotype, but here's what Snake and I were trying to you know, come to an agreement on in the first 45 minutes there. It isn't absolutely neutral to the genotype. Can we at least agree on that?
Well, yeah, obviously, once you have a change and it, you know, it's not neutral, it's relatively neutral, but not
Relative, okay.
absolutely.
Relatively neutral, near neutral, relatively the same thing. So
unless it's a silent mutation.
Right. So it's not like, for example, you know, the redundant elements that Snake and I were talking about earlier. You know, the cell uses different redundant elements to slow and speed the process. Right. We know that our genome is highly compressed, and we know that, I mean, there's tons of papers that talk about how proteins are doing things you wouldn't even expect, right? Protein moonlighting, for example. So at the end of the day, if RNA was always underappreciated, we know Richard Dawkins underappreciated RNA. That's a fact. And we know junk DNA is decades ago biology, and there's massive literature showing so many unexpected, unimaginable functions in RNA. Is it science or is it pseudoscience to say that the majority of our genome is based on, say, evolutionary leftovers, evolutionary fossils, relics, and that a mutation in a non-coding region, like Snake said earlier, is absolutely neutral? I mean, to me, that's pseudoscience. You just admitted it's going to be relatively neutral, but not absolutely neutral to the genotype, right?
But what about that 20% that has been found to have no biochemical activity?
Let's just say that 20% is absolutely useless. Junk, non-functional. This paper that you brought up, Snake, states that anything more than 10% makes human evolution very problematic. But anything over 25%, the paper states human evolution is impossible. So I'll give you, for the sake of argument, 80% of the genome is functional. That destroys evolution, because now the 60 to 100 new mutations per person per generation, that means 80 of them are deleterious or whatever it is. That's horrible. Even if 2 or 3 of them were deleterious and not selected by natural selection, that still is greatly problematic to evolution. You can still hold on to the philosophy, of course, but that type of change.
It's a misunderstanding about
are you saying that
the different ways that function is used? Because ENCODE is using it differently than how most evolutionary biologists use it.
How much of the genome do you believe is functional, percentage-wise?
I think the study says about 15%.
So more than 10% is problematic.
But notice that they're using the word function differently.
Well,
in the different studies.
See, the thing is, though, these evolutionists, they have a bias and they have an adherence to universal common ancestry, okay? So obviously they're going to downplay the results found by ENCODE that at least 80% of the non-coding DNA is actively transcribed in RNA. I'm saying it suggests function, yes, okay? It's preliminary data. But based on the list of things that came to mind that the non-coding DNA is involved in, and I'm sure there's more. If I were to Google it, I'm sure we could find more. The fact is, I think it's pseudoscience to say that only 15% of our genome is transcribed. I mean, just look at the trajectory of discovery. Like I said earlier, back in the 70s, what did scientists think? One gene, one protein, one function. Emotionally stunted emoticon. He's a smart guy. He probably knows that. Now, so many discoveries. You know, massive literature showing unexpected function of RNA. Guess what? We're only in 2019. What happens in 2029, 2039, 2050? We are predicting that the vast majority of our genome is functional. Do you believe that that is such an outrageous prediction, Snake?
A little bit, but
Why
because
is that?
we
If you
have we have already studied which parts of the genome are functional.
Well, how many
Not everything, but
how many knockout experiments on humans have been performed?
no humans, but on mammals.
Right, so it's unethical. So I think it's premature to make the claim that the majority of non-coding DNA is non-functional. I'm going to let you respond. One other thing too is what the DNA is doing on a molecular level, step by step, and the fact that we are just beginning to understand the developmental process, right? How coding and non-coding DNA coordinate, where, when, and how structures are sequentially put into place to produce that fully functional organism, from the embryo to baby. I mean, the amount of activity, the amount of roles involved in that, and we know so little about it. So that alone is probably going to account for the other 20%. But it sounds to me like you have to hold on to your evolutionary bias. I'm sorry to use the word bias, but that's the only thing I can think of as to why you're just ignoring the obvious. You know what I mean? Because I think in one of our debates on MDD, I think I've got it recorded, you said 25%, but now you're saying 15%. Like, why the change?
Well, I think the study says between 15 and 25. 25 is like the upper limit, like the absolute.
Well, I know what the study says, and I know what the study concluded. So therefore, they have to conclude functionality percentage-wise is under 25%. It has to, or else human evolution is impossible. We, as creationists, we can take it to the logical
coding
conclusion.
regions.
No, you said non-coding regions. Coding and non-coding combined.
Non-coding would be the majority.
Right. Yeah. The majority is non-coding. Of course, everyone knows that. So the genome-wide functionality. What's the percentage you believe is playing roles? Let's say playing roles, whether it's coding for a protein, involved in embryonic development, stagings of proteins for construction of molecular machines, whatever, just roles in general. How much of the genome percentage-wise do you believe is actively, is not idle, is active to some extent? How much?
Well, it doesn't matter unless I'm agreeing to 80%. It's a minority. It's like, it's somewhere under 25%. So
so it's got to see, and that's your philosophy, and that's fine. Okay, it's not science. You have to have it under 25%, of course, no matter what the literature says, no matter how much has actually been overturned. This makes generation that much harder for you.
But that comports with the evidence. It comports with the number of what we've estimated and tested are the functional genes, and I don't think there's any evidence for diseases or problems with mutations in the non-coding regions.
Well, and that's your belief again. But of course, like I said earlier, listen, for the audience, it's good to make it understandable, interpretable. If you have the Bible and you make one single spelling mistake in that Bible, I agree. It's neutral to the Bible as a whole, but it's not neutral to the information content. Okay, it's nearly neutral, as emotional Stunted Emoticon said. It's nearly neutral, but it's the buildup of them. Okay, so let's not bore the audience. Let's agree to disagree on junk DNA. Okay, so the next thing you mentioned was beneficial mutations. Do you believe beneficial mutations can counterbalance the influx, the relentless influx of these deleterious mutations? So whether it's 60 to 100, but then you can debate how many are neutral versus deleterious. To be honest with you, just a few of them being deleterious is still a problem. So for sake of argument, I'll just say a few of them are deleterious. Can beneficial mutations counterbalance the damage?
Well, I wanted to.
Go ahead.
Well, I just also wanted to say that also for the audience, but as well, I think I'm having this conversation at least so we can at least understand each other's positions, not necessarily agree, but just understand.
No, I understand your position, of course. Do you understand mine?
I think I do understand it.
Okay, well, that's good. That's good. So, and you know what, emotionally stunted emoticon, I want to give you some time too. So why don't you define what you believe a beneficial mutation is? Maybe give us a couple examples of them, and then tell us how those can counterbalance the the relentless influx of actual deleterious mutations. And another question too, how rare do you believe beneficial mutations are? Take your time. You're a guest here. Thanks for joining, brother. I hope we can do many of these. Go ahead.
Okay. So the first question you asked, if beneficial mutations can counterbalance the deleterious ones. Yes, but according to the situation you're talking about. With humans and dogs and cows or whatever, these animals are domesticated, as I pointed out to you. So they are
Right.
not under any kind of harsh selection pressure. So of course they would expect a buildup of deleterious mutations in these populations. Populations that are inbred, again, it's expected that it's going to build up. However, populations that are not under any kind of domestication or is not being affected by inbreeding, they would be able to counterbalance the beneficial mutations is going to accumulate. That's why you don't find populations that are not inbred or not domesticated suffering from the same kind of pandemic we have, because we are domesticated.
Okay, so let's see the first thing you said. So are you agreeing though that, say, inbred populations, let's use some examples, the papers that come to mind just so we can back this up. So mammoth population, highly inbred, carried an elevated genetic load, possibly led to their extinction, okay? Early human populations, Neanderthal, hobbits, Homo naledi, Homo erectus, it appears they were also highly inbred, maybe due to isolation, according to our model, post flood, post Babel, because we see, reduced body size, reduced brain volume, other pathologies, right? I mean, that would be the hobbits, for example, but Homo naledi, Homo erectus as well. That's why I'd put naledi and erectus into probably the more diverse, well, obviously, erectus group. So we see that. Also humans. So you'd say humans are obviously domesticated. The selective pressures are different, correct?
Right, correct. We are domesticated, so there is no selection pressure really being applied here.
Right. Would you? Okay, so we're on the same page with inbreeding. Everything I just said. Now humans. Okay. Do you believe that there's a pandemic? Alzheimer's, asthma's on the rise, immunological diseases, autism seems to have a genetic component to it. Autoimmune diseases, cancers. What's cancers now? 1 in 3, 1 in 2. But it seems like we're on the same page with all of this. But you're just saying it's mainly because it's inbreeding and domestication, right?
Right. Those two. There are other factors as well, but just mainly those two factors we would expect that even under an evolutionary model. So there is no conflict between me and you here.
Okay.
So
how come
both models are pretty the same thing? Yeah.
But how come so many evolutionists I talk to, and which is good, because I notice you don't look to bacteria as a as an argument or a challenge to entropic degeneration. But let's say humans, and we're going to get onto your bigger argument here, of course. But I just want to be on the same page. How
You're glitching out
in regards to humans, right? All these different diseases, and I know what you attribute it to, domestication. What's that?
Did you catch that, Stunted? Because
No,
you glitched out there for a little bit, SFT. At least for me.
Yeah, it kind of broke up. Yeah.
Did I?
Good question. Yeah.
Okay, here. You can hear me.
You're cutting out again.
Actually, Stunted Emoticon. For one, we're going to get into your bigger challenge there. How can selection, though?
Huh.
Okay, just one sec. Maybe it's my connection. Okay, how about now? Good?
It seems better. Yeah.
Good, you can hear me now? Okay.
Yeah.
So it's just that part then, okay. Yeah, so emotionally stunted emoticon. So inbreeding, domestication. Okay, then we'll get onto your bigger argument and challenge after. That's going to be fun. Now, if there's a pandemic, 60 to 100 new mutations per person per generation, we see entropic degeneration on all levels, say humans, for example, all these different diseases. Right. I'm just curious, what type of selection can counterbalance or stop? I understand selection can slow. It can slow the degeneration, because we both agree selection can amplify the best beneficial mutations, and I'm sure I'm not going to disagree when you bring a few up. I will say that they're probably reductive, but we'll get into that. And it can rid the population of the most detrimental. But the actual entropic degeneration currently in humans, how can we reduce? If you watch Dr. John Sanford's lecture at NIH, he concluded at the end, we need to reduce human mutation rate. You know, that's a must in order to at least slow down this mutation accumulation. You know, what's your resolution? I'm just curious.
Right. So as long as you have sufficient selection pressure, then you would be able to weed it out. It's evidenced by the fact that we don't see it in populations that have that type of selection pressure.
But what about humans?
Humans are not under that kind of selection pressure. We are pretty much
right. No, and I agree with you. I'm just saying, what's going to stop then the eventual degeneration of, because if we see these inbred populations, which I say is just small scale genetic entropy, okay, you know, inbreeding reveals the hidden reservoir of genetic mistakes, okay, so it speeds up the degeneration process. I think we agree with that. But what's going to, and I understand you believe humans are domesticated, so you would expect this, I guess, you know, but is there any way that's going to stop the eventual extinction of humans?
What can stop it? I'm not too sure if it's going to stop or if it's going to continue. I can't say much on that. But the quote unquote pandemic you're talking about, it isn't going to go away anytime soon.
Okay.
So we're going to always have that quote unquote pandemic because of our lifestyle.
And that's a very good answer. So the thesis of genetic entropy would be that, you know, humans are on their way to extinction based on the fall accumulating, and we know genetics plus environment equals phenotype. So it's environmental, it's epigenetic. That's why I was saying entropic degeneration at all levels. So if probably nothing can stop the eventual extinction and degeneration of humans, that's technically your main thesis of genetic entropy. Okay, if we agree on that, now you want to go.
Well, genetic entropy is basically saying that this kind of degradation is ubiquitous. It happens to every single life form.
Well, Dr. John Sanford states that his thesis is not more so that everything is going to go to extinction, although he does agree that eventually, yes, all species will. But it's that accumulation of mutations, the fact that mutations, whether beneficial, neutral would be near neutral, but beneficial or largely reductive, they're not going to be able to drive an evolutionary process, number one, okay? Number two is that, yes, humans, okay, based on the high mutation rate, based on the population size and numerous other factors, they will eventually go extinct. Now, your problem is just other species, right? So if you want to... If you want to go over your main objection there, I'll address it. So take your time and make your case, brother.
Right. So it's not big of a case. It's just basically the same type of accumulation of deleterious mutations you would see in domestic. You can even see that in wild and domesticated. For example, I think Matt. Oh my gosh, he was talking about a species of sheep or species of goat, and the wild type had less deleterious mutations than the domesticated type for obvious reasons. But the wild type was not suffering from an influx of deleterious mutations as opposed to the domesticated type. I forgot the exact species. I got to get that for you.
Well, since Matt's the one, so you're saying Matt brought this up. Matt, did you want to jump in there real quick, brother?
Oh, sure. I sent him a lot of reports. He wanted to know, like, what type of animals show that they're building up with deleterious mutations. And since everything's just on the keyboard and typing. I guess I don't convey my message very good. So what I was trying to do is show him that every species that's ever been tested with a mitochondrial clock is using mutation rates based off that. That's how they actually build these clocks. So any study you find on mitochondrial observed rates or genealogical methods known as trio rates. So you'll find the fast compounding mutation rates in, oh, sorry, what did you say? Oh, I thought you said something. I just see your icon pulsating. So anytime you see these mitochondrial clocks, you can look at everything. It doesn't matter if they're wild or inbred. Nematode worms, roundworms, crocodiles, alligators, birds, beetles, tortoises, penguins, water fleas, polar bears, chimpanzees, gorillas, Tasmanian tigers. They go back, even snakes. Everything that they've tested is extremely fast. Everywhere from 7 to about 100% faster. So those tests are what you're looking for when it comes to these mutation rate buildup.
Right. So again, the rate of mutation, I don't have a problem with that. It's the rate of the buildup of the deleterious mutations. Are they seeing that in those kinds of populations? In populations that are not inbred or domesticated?
Oh, the deleterious ones. Well, it's usually based on a percentage. They usually find about 1.6 to 3 deleterious mutations build up per 100 neutral mutations. And because in these rates, in these clocks that they build up every generation, these trio methods, they're looking at genealogical. So they're looking at grandparent, parent, and son. So they actually are looking at 3 generations every single time, and each one has a compound of 100 mutations each one, and they actually find that they do have about 3 to 6 deleterious mutations in each generation building up. So those are the mutations that you're looking for. I can get you the technical papers on whatever one you want, really. I have them all right here. So like, let's say if it's the sea tortoise, they actually found that the mutation rate in those is 20 times faster on the genealogical methods. And these giant tortoises aren't in zoos. These are the wild ones. And they've actually found that their mutation rate is quite high, and they live in the wild. But that can also be because of pollution in the oceans. So there can always be some kind of a rescue device, you know. But I mean, if you want to pick an animal, I'll give you one.
Right. So if it's due again to pollution, remember, pollution wouldn't be something that would affect species over millions of years. We weren't around for millions of years to pollute. So again, it can't be due to pollution. It has to be something independent of pollution as well, because we weren't around. On an evolutionary model, pollution wouldn't be a factor to affect species.
Right. Yeah. But unfortunately, we don't have any animals that are living in the world longer ago, you know, that we can look at this mutational load in. We can only look at the current species that are alive, and the whole world is pretty much polluted right now. So we're kind of out of luck with that. We do have ancient man. I made a video on that where we actually showed that ancient man had far less mutation load compared to modern day man. And that was one of the ways that we were looking at our model to prove it. But since you don't want humans, we got to stick to more animals. And that mutational load, deleterious mutations is what we're looking for. So we can look at things with disease. So a great example of this is when we're seeing species dying. And the polar bears are a great example because we're losing them. And they are horribly bad right now. Hello?
I'm here. Can you hear me?
Okay. I hear somebody talking again.
Yeah.
My bad. I don't. Okay, yeah. So polar bears have about 15 diseases constantly in almost every one that they test, from everything from fur loss to genetic diseases to digestion problems to not being able to produce enough fat. They have huge problems, and all of them are linked to gene. Matter of fact, try to name to me a cancer that's, and I'll name you the gene that it's linked to, because we're finding that everything is linked to a gene that's linked to a deleterious mutation. So if everything, including cancer, is linked to a mutation, where's the mutation getting rid of these things that's going to be beneficial? They're not there. We're just destroying our bodies with mutational load. So that's what I'm getting at. We just see problems. And if there's supposedly these beneficial mutations that are counterbalancing it, well, where the hell are they? Cancer is growing, and none of these mutations are anywhere to be seen. Every cancer they've ever found is linked to a deleterious mutation. Everyone. I can name them off to you. So we see the same thing in animals, but people study humans more. They only worry about animals when they're starting to go.
Yeah. Yeah, I do agree with you that we do study humans more, but again, now I am willing to accept your thesis on genetic entropy, but it has you have to show me that it's happening to all species under all conditions. Because again, the conditions that we have for like for example pollution and so on wouldn't affect evolution again because we weren't around for millions of years, so that's out of the game. Um, so it's only species for now. The only thing that have been shown is species that have been inbred or is inbreeding or domesticated that is suffering from the accumulation of the terrestrial mutations. And so it seems to me that once these species are not affected by pollution or the inbreeding or the domestication, then they would be just fine.
Okay. Oh my God! Somebody said cancer is fake in the comment section. What? What does that mean? That's a troll right there.
Is it virtual Maya?
No, Derek Sanders. Cancer is fake.
Oh,
I don't even know what that means. Oh wait, he removed it. Okay, moving on. I guess.
there's a guy. I think his name is Virtual Maya. He argues that bacteria is not real. No, not bacteria. Viruses are not real.
Bacteria. Oh, viruses too.
Yeah,
Wow.
viruses they're not real altogether. Yeah.
Well, viruses unfortunately exist. The good thing is we're using them to our advantage right now, and we're actually being able to change. Matter of fact, if you want to have blue eyes and you have brown eyes, what they're doing is they're taking viruses and they're stripping them, they're removing everything that's inside of them, and they're injecting the gene that makes blue eyes, so it overrides your brown eyes, and then they're injecting them in the viruses because they never die. Now you have more dominant alleles to have blue eyes, and you have blue eyes the rest of your life. So pretty crazy.
Wow.
Yeah, so emotionally stunted emoticon. I'm kind of curious on your thoughts here then, because let's say if you're expecting to see evidence of genetic entropy within a biological setting that is, say, not due to inbreeding, not due to domestication, because I mean we see, genetic degeneration in those cases, of course. We all agree with that. Actually, Snake, do you agree with that? Because you seem to always, bring up your compensatory mutation, synergistic epistasis, what I would call your rescue mechanisms, also on domesticated, like for example, humans. Taylor, do you agree humans are degenerating presently?
It's possible due to the fact that we don't have any selection pressures, really, at least in some countries.
Was that always your position, though? Because I don't remember that being your position, because we used to argue hours on just that, and it's kind of nice that emotionally stunted emoticon kind of at least conceded those types of genetic entropy. Now we're on to non-domesticated type of species.
No, I mean I've thought about that before. It's because we aren't selected to selection pressures anymore. So people who do have deformities are breeding minor, even to severe deformities, whereas in a natural setting they wouldn't.
Okay, so I am curious with emotionally stunted emoticon here. Let's say if you expect to see evidence of genetic entropy, say within a biological setting, non-domestication, we would need an experimental organism that has both a short generation time and a relatively high mutation rate, because obviously long-lived organisms such as mammals, a genetic entropy experiment, minimally it's probably going to have to last hundreds of years, right? Especially if these near neutral mutations are invisible and they have such tiny effects. It's tough to see them in real-time experiments. But let's take something that has both a short generation time and a relatively high mutation rate. So for example, RNA viruses, which I believe are uniquely suited for that purpose. If we could see RNA viruses degenerating quickly based on the fact that they have, both a short generation time and a relatively high mutation rate, would that be convincing evidence to you or no?
RNA virus. So you wanted to see in a natural setting. Okay, so what I have to do is to find a population that is that has that high mutation rate, not inbred, not domesticated, and test them to see if they do have an influx or of deleterious mutation, if they have a heavy load of deleterious.
But I'm just saying, like, if we were to look at something that has short generation time and relatively high mutation rate, you know, that could be, you know, genetic entropy on a small scale versus, say, long-lived mammals on a long scale, right? We can see if it occurs in this type of, like, for example, an RNA virus, you know, they have short generation times and a relatively high mutation rate. So if genetic entropy is true, shouldn't we logically see something like that? Because, for example, bacteria, they have short generation times, but they also have a lower overall mutation rate. But RNA viruses, they have short generation times and a high mutation rate. So the fact that we've seen, let's say, the H1N1 human version, for example, we've seen the H1N1 human version go from a red hot pandemic to a whimper to an extinction event in 90 years. Now, from what I understand, the evolutionists, and I'll get your input here, they don't seem to know why exactly the H1N1 virus went to extinction, but I believe they chalk it up to adaptive evolution. But I don't see how adaptive evolution could cause extinction, because it looks like the virus, okay, and there's a really, really technical paper on it. So I'm just going to kind of go with, in a nutshell, from what I know, it looked like the virus started off more human in its codon usage and ended up randomized. It became worse, okay, at interacting with human DNA over time. And if it is using the wrong codons, that means it will be less efficient at replicating in human hosts. So it looks like there is a decline in functionality, and it matches exactly with genetic entropy. It also explains why the mortality rates went down, and it also helps to explain why the strain went extinct. So is that not genetic entropy in real time? Would you accept that as evidence, or no? And if no, why not? Go ahead.
Again, I'll have to investigate the circumstances of what caused it to go extinct.
Okay, good.
Again, I'm not too sure if it's maybe the host environment, the human, if maybe humans found a way to combat the virus and then it went extinct that way.
Well, it
But
looks.
I'm not too sure. I'm not too sure the exact consequences that caused it to go extinct.
Well, it looks like the codon bias declined consistently over time. That wouldn't be consistent with adaptive evolution as far as I'm concerned. And it shows clearly that they got worse, so not better, at interacting with human DNA. Now that correlates to slower replication, and that also means less lethal infection. So the viruses became less lethal because why? Well, they got worse, not better, as I stated, which is exactly what we would predict. At doing their one and only job, which is replicating themselves. So short generation times, high mutation rate. It's been studied, very technical paper, peer-reviewed, I believe, in the NIH journals. I'll send you the paper, okay, because it sounds like you are genuinely interested. I'd like to see your feedback. But, you know, that seems to be genetic entropy in real time. So if all turns out well after you read the paper, would that be sufficient for you to validate the genetic entropy thesis? Go ahead.
Sure. Again, if I do read the paper and I find that it seems that the virus itself was getting weaker instead of the human immune system getting stronger against it, then sure, then it should count as genetic entropy.
Because now there are swine flu versions, though, now circulating. So, you know, that.
But that is evolution. Some changes worked, some changes did not.
Yeah, but this went literally in 90 years, Snake, from a red hot pandemic to a whimper to an extinction event. They got short generation times, high mutation rates. So,
but other strains are still extant. They survived. They didn't.
Of course, and I believe they are also now experiencing degeneration as well. So they're on the verge of extinction as well. Just like, because remember, it took 90 years for the H1N1 human version to go extinct. Now, I mean, the paper is really, really technical. It's long. It's peer reviewed too. So, I mean, I'll send that to you guys and see, because obviously if we agree that there's degeneration in domesticated animals and species, inbred. But the thing is, I mean, RNA viruses in general, they are known to be prone to error catastrophe and spontaneous mutational meltdown. I believe that that's pretty well documented. Don't you agree, Snake?
Yeah, some of them.
But the thing is, viruses can also persist for very long periods of time in a dormant state, and then they can reemerge from natural reservoirs. So, you know, whatever's going on with the swine flu versions or whatnot. But I mean, the H1N1, it did go extinct. That's a fact. You know, read the paper, see what your explanation is to it. But and then even
How come this mutation accumulation rate is not uniform in all populations?
well, it depends on, so for example, RNA viruses, you got, you know, short generation times, high mutation rates. That's why they're a good candidate to look for experimentally for genetic entropy. We got humans, 100 new mutations per person per generation. E. coli bacteria, I believe, is about 1 in 1,000, plus way more rounds of selection.
Yeah, bacteria actually have a really high mutation rate.
No. They have an overall lower mutation rate.
And what do you mean by that? Overall lower than what?
Well, they have 1 in 1,000 cell divisions is roughly a mutation in, I believe it's the E. coli. In the paper I have talks about E. coli. That's about 1 in 1,000, which is a fact. I debated Dr. Stefan Frello, and he had that published. Yeah, mutation rate.
Well,
E.
the
coli.
mutation rate in bacteria is about twice that of humans per generation.
No, humans are 100 per person per generation. Bacteria such as E. coli is 1 in 1,000.
What you cited the other day in a video I watched was 1 times 10 to the negative 9th for bacteria per generation per division, and in humans per generation it's 0.5 times 10 to the negative 9th, which is exactly half.
Well, what I stated was bacteria, they are, well, for one, E. coli, for example, 1,000 times smaller than that of humans. They're also, you know, bacteria are more specialized and perform fewer functions. That means any letter change is more likely to do something that natural selection can see. So that's the whole point. I mean, nobody, you know, genetic entropy doesn't predict that bacteria will actually go extinct first. Because, you know, it's more likely that a small change will produce in a bacteria a large enough effect that it will make a difference in the number of individuals, say, carrying that trait generations later. But I've always said it's about 1 in 1,000. So I'm not too sure where you, I mean, like I said, Dr. Stefan Frello, same thing. You can go look at his debate with me. He had it cited. It's about, you know, it's 1 in 1,000. Matt, I think you have the paper that confirms that. But regardless, I mean, bacteria are more simple organisms, and they have a lower overall mutation rate. Do you disagree with that?
Lower than what? I mean, I just made a video about this, like responding to that video, so that'll be out tomorrow.
Yeah, that's fine. So if you made a video then, so if we actually look at, let's use, are you familiar with Lenski's experiment? Like, what do you know about Lenski experiment, the Lenski E. coli experiment, Snake?
Well, there were populations that improved their overall fitness, and some populations that did not, that went extinct.
Well, in a narrow sense, there were some adaptations observed, but in all 12 in all 12 experimental populations, the functional bacterial genome size has shrunk. Like, there's literally less total information. You know, they've actually lost genes for adaptive purposes, but at the end of the day, the net effect in the long run is degeneration. So I understand that according to your philosophy that's still evolution. But
is that in the study that there's degeneration?
Yes. It talks about that
for every single population.
The 12 experimental populations, the functional bacterial genome has shrunk. There's papers documenting the beneficials that were observed. Okay, so yeah, it It is documented, and a lot of it was due to loss of biological functions, loss of,
Yeah.
well, I mean, reductive evolution is known in bacteria. You can look for papers, reductive evolution in bacteria, and you'll get a ton of papers. Bacteria are just known to do that. You know, they'll lose genes, especially in artificial environments, you know, genes that are not necessary in that environment. They'll adapt by losing genes. It's adaptive optimization. But to be honest with you, it's eventually stasis. I think it's called escape from adaptive conflict. Matt, am I using that term correctly?
Yeah, exactly. That's when a gene usually has about 4 to 5 different functions, but it drops and reduces itself to just one. Yeah, that's kind of what the bacteria did, because now those bacteria in Lenski's experiment, they were only fed one type of food, so they got lazy. They actually don't move, and they can never live in their original environment like the other bacteria can again. So, all bad for them.
So I know, so Snake, you love, yeah, great points, Matt. You love to go to the fossil record, you know, to validate, you know, universal common ancestry. But if we look at the long-term E. coli experiment, I think it's more than 60,000 generations now. Matt, what is it? About 100,000 generations now?
More. Yeah.
Okay.
It's way up there. It's approaching almost 2 million years of human evolution.
So what's funny is this famous evolutionary experiment, okay, proves that in deep time, which you're looking to, Snake, when you look to the fossil record, even given a model population that should be optimal for validating evolution, proves that populations don't evolve and instead they devolve. So I understand that you stand by your philosophy, but based on this real-time observable experiment, it's science fiction. You know, it's
Well, it actually proves that they survive a lot longer than they should if there was genetic entropy, and they have evolved new proteins and new functions.
No, they've.
I don't think this is really that productive, because I can admit like that there is genetic entropy. There might be a time limit on life forms, but that doesn't really comment on evolution. Like, I could even give you that the dating in the fossil record is off, but that doesn't really affect the theory of evolution.
See, but the thing is, you know, you said that fitness was increased in this experiment, right? But the thing is, you can even look at the paper, like this fitness increase, it's only in a narrow sense versus a broad sense, because in broad sense, if you're gonna, the best definition of fitness is total functionality. Would you not agree?
That seems kind of like a word salad.
Okay, well, what's your the best definition of fitness should be total functionality, not just looking at a single trait.
Fitness for your environment.
Right. So the fitness for this environment was like if you use the full meaning of fitness, total functionality given this environment, all 12 of the population have experienced a net loss of function. And so they have reduced total functionality as needed in the real world. Okay. Yes, to adapt to this environment, they've lost genes, but bacteria do that in the real world too. So real world
they've gained function in some genes, and the genes that they've lost function for, I mean, those can be beneficial mutations. There are loss of functions that are beneficial.
Well, yes, according to like your belief system, you know, losing genes and, you know, breaking down pre-existing functional systems is going to take your bacteria-like organism to a biologist, but there's no science to support that. In our new house, we tore down, just one sec, in our house, new house, you know, we're doing renovations, we tore down the wall that separates the kitchen and the living room. That was adaptive. But guess what? We destroyed that wall that separates the two rooms in order to make a bigger room. Now, at the end of the day, if someone told me, how'd you build the house? And I told them that, well, that's not explaining how I build the house. It's just like these bacteria, you know, it's a net loss of information. You look to a trade-off, of course, but the question is the trade-off sustainable? And obviously it's not, because if fitness is increasing in a very narrow sense, okay, you know, a certain portions of the genome is increasing in fitness, but the greater portion is simply just losing information and degenerating. Well, at the end of the day, if it comes down to a net gain versus a net loss, that's a net loss of fitness. And you can disagree and say, "Oh, that's evolution. That's how evolution works." But there's no science to actually back that up. The long-term E. coli experiment, the largest evolutionary experiment there is currently, proves creation and not evolution. Go ahead.
Well, we could be evolving towards these total mutants, and it still wouldn't really comment much on evolution, especially since you haven't calculated a time limit on any of these things. And the time limits that we do know of are pretty short.
Matt, wasn't there a time limit, Matt?
Oh, yeah. Dr. John Sanford predicted the extinction of the human race in 1997. He said at 350 generations. We're at 303 right now.
Okay. Well,
see the thing. Well, I mean, that answers your question, right? So the thing is,
that doesn't happen. I got how many generations do we have left? 47.
Yeah,
I guess we'll all be gone by then, unless we all eat fruit.
Oh yeah.
We're all gonna go on the raw. We're all gonna go on the raw mat diet. Well, I want to say one final thing here. So, at the end of the day, Lenski's team of researchers, they did sequence the genomes of these E. coli, so they were able to track all the mutations that arose in this experiment. Now, when these key mutations were examined, so there were some beneficials. Like I said, I've never disagreed with beneficial mutations, but they are environmentally dependent, and it's about context. But it is clear, given the data, that the beneficial mutations, they did involve loss of function. I think one was even based on a disrupted regulation. And this long-term E. coli experiment, it's not undergoing rapid evolution there, Snake. It's actually undergoing rapid degeneration. I mean, that's the exact opposite of what you need to take your fish to fishermen, to build a genome. You're not going to build a genome by degrading.
Like synaptic pruning, because children are born with more synapses and more brain cells than adults, and we actually gain more information by losing brain cells.
Wait,
you're saying what's that? Were you going to say something, Matt?
I've actually studied that they've actually found the losing of intelligence and emotional abilities from mutations recently. Matter of fact, the science, Cell Press, the Journal of Genetics, they suggested that we're losing our intellectual and emotional capabilities due to the increased web of genes that are endowed in the brain for susceptible mutations. Based on their calculations, they even said that the frequency of deleterious mutations in the human genome are said that we have about 120 generations left until we've sustained more harmful mutations. They said that they're linked directly to autism and things like that. I can find that study for you.
And we all become psychopaths or something.
But
there are genes where, like the HIV resistance, for example, the inactivation of that gene confers a resistance, and there's no negative effects that are known. And in whales, the baleen gene is just a part of a normal tooth gene. So you can actually take away information and get a different meaning from it.
Now, what on a genomic level happened in this H1 or the HIV-1 immunity? Was it a loss of evolution, or what was it on a genomic level?
Go ahead, Stunted.
Before we get back to the sorry about that. Before I get back to the H1 virus there, I wanted to say something that on a macro scale, any transition you have, it would actually require that you lose some things for you to adapt to a specific environment. I heard you said that that from your fish to a fisherman, you could be losing stuff and get that. Actually, it would require that you lose the entire fish. We're not fish anymore, so we'd have to lose all the features that are diagnostic to fish that we don't have. We lose the ability to lay eggs. We lose even Matt did a video where he was saying that if we have evolved from apes and we have lost everything. Yes, we did lose a lot of things, but that's how evolution works. Go from the evolution of, for example, whales. They lost a lot during their evolution. The evolution of horses, they lost their toes. Birds lost their fingers and some bones, etc. So they lost their teeth and tail and so on. So every transition, even on a macro scale, that's exactly how evolution works, by losses and gains, in this kind of, as you call it, a state from adaptive conflict or trade-off or whatever. That's how it works on a macro scale.
Right. No, I understand that that's what the evolutionists believe in regards to the novel gains, the changes that lead to novel structures. But at the end of the day, we just don't observe that in real time. I mean, we're looking at a real time example, thousands and thousands and thousands of generations of E. coli, and we've observed a net gain or a net loss of information. Bacteria produce more bacteria, and it turns out they're more degraded bacteria. So I understand, the evolutionary story and what the evolutionists believe, but think about it. Every new form of animal life has new anatomical structures, new organs and tissues in new body plans. And the thing is, organs and tissues are made up of distinct cell type. So for example, an animal with, a gut, let's say, is going to need digestive enzymes, and enzymes are proteins, and proteins are built in accord with the information stored on another molecule. So random changes in the sequence of the DNA letters and change in allele frequencies and over time and losing structures and losing information, like you said, will lead from a fish to a fisherman. But at the end of the day, that's a belief. We don't observe that though.
It have gains as well, obviously, but it would require some losses and some gains. And when you were talking about that, the bacteria adapted to a new environment,
right,
and they can operate properly in their old environment. That's again how evolution works. Right? For every major transition, for example, again, if you go to whales on a macro scale, whales can no longer live on land as they should. Because they lost the ability to live on land. Doesn't mean that they're degraded or whatever. That's just how the process works. You lose some, you gain some. You adapt to a new environment. You lose the ability to live in the old one. That's pretty much how it goes.
Right, and I accept that's what you believe. But as we've demonstrated here in the longest running evolutionary experiment, at the end of the day, that's not what we observe. You know what I mean? You're saying that whales, bacteria, humans, and say fish are all related through common ancestry, and that's a fine belief to have. But you're saying we need loss. Okay, well, that's pretty well what we see, 99.5%. Even if there is a gain somewhere, somehow, that simple gain is not going to counterbalance all the loss. We see destruction, extinction. I understand, the evolutionary story, but at the end of the day, there's just no scientific evidence to back up that story. Like, you can have beliefs, but you need, even if you so you're looking to the whales, for example, and at the end of the day, it seems like the whale story is constantly changing. I mean, wasn't Pakicetus, for example, wasn't that at one point assumed to be a fully aquatic mammal and was even advertised as a fully aquatic mammal? But now there's been this drastic revision, and now it's just portrayed as an ordinary land mammal. So that seems to be far from, a primitive cetacean. You probably could talk better on the details of that emotionally stunted emoticon, but am I accurate in that?
Well, again, it's based on the evidence that they had at the time.
Right.
Maybe the bones that they had before may have suggested that it seemed like an aquatic animal, but then with new fossil finds, they changed the conclusion. Remember, it's always the evidence that makes them change the conclusion. They don't just change the conclusion just like that. So if you
right,
if you have new evidence,
it's changing. Like the story constantly
right, it has
changes.
to change. If you have this data, then it needs to change.
It's just a question of like
All theories,
what kind
do that.
of swimming did this terrestrial animal do? Did it do a lot of swimming or not a lot of swimming?
Right, like even if you look at like Ambulocetus, for example, as a transitional form, I think his name is Dr. Gendrich, at the University of Michigan, he's actually noticed a very crocodile-like feature of Ambulocetus. He even doubts, and he's an evolutionist too, he's not a creationist, he now doubts its inclusion into the whale lineage. And he writes, he says, Ambulocetus has its eyes raised up on top of its head in a very strange way, and it is unusually large for an early whale. Maybe it's not in the line of, or the main line of whale evolution. So unlike whales, right, that have eyes on the side of their head, okay, it looks like Ambulocetus had eyes near the top of its head, similar to a crocodile. So it just seems like if some of these leading evolutionary experts are now even adjusting the story of Ambulocetus as, say, a whale intermediate, just like the story changed in regards to Pakicetus, shouldn't, say, evolutionists like Snake and well, you guys seem to be honest. I mean, you guys should at least be a little more upfront with, the questionable nature of a lot of these so-called evolutionary ancestors or transitional fossils, right? Like, have you heard of that emotionally stunted emoticon, and what do you think about that? Go ahead.
What we have to find, what you have to realize first is that no transitional fossil is ever going to be the direct ancestor of any other fossilized life form or extant species.
Right. Yeah.
They're just branches. So none of them are the direct ancestor of anybody. You can't prove that anyway. The only way you can prove that is if you watch and trace every birth along the lineage,
right.
which is impossible.
Good point.
No fossil is ever deemed as the direct ancestor of anybody.
Right.
So finding a fossil that is maybe an offshoot of the major evolutionary lineage, the whale, isn't a surprise. That's just the branching nature of evolution. You may find more fossils that would look more similar to what may have been the actual ancestor, but it's never deemed as the ancestor. I mean, if you look at a cladogram, it's never lined up in a lineage of direct descent. It's always a phylogeny of cousins, so it's never a line of descent. So again, I would agree that it is not a direct ancestor, as you said, for obvious reasons.
And I appreciate that response. It just, I think my whole argument or my whole position would be based on, what do we observe today? We see, for example, in this long-term E. coli experiment, we see adaptation through degenerative means. It seems like we see entropic degeneration on not just one level, two levels. It seems like it's on all levels. I think in regards to, let's say, whale evolution, since you brought that up, it seems like, the presumed, transitional forms that I hear the most of, Ambulocetus, Pakicetus, Rhodocetus, we've talked about two, Pakicetus and Ambulocetus. They seem to be highly questionable. Stories seem to be changing. And these whale precursors, they seem to be based more on speculation, wishful thinking. And I think in general, the fossil evidence and these reconstructions based on the fossil evidence, they seem to be based mainly on a few scattered fragmentary fossil remains. And some of the distinguishing bones that you would need to make an absolute conclusion and argument, they seem to be generally absent. Not saying all of them, but some of them. So, that would be my response. And I do want to say this, you guys are my guests here. I'm hoping to do this maybe once a week where we get you guys in. New topic every time. Today we talked about, genetics, genetic entropy, junk DNA, emotionally stunted emoticon. I'd love for us to talk a couple hours about, the LMN haplogroups and predictions, nested hierarchies, these types of stuff. It's getting late here, but I want to give you guys the final words, and Matt as well, give your thoughts. Maybe we'll start with emotionally stunted emoticon. Say what you feel needs to be said in regards to, what I've stated here. Then Snake, then Matt, and then hopefully we'll do this again soon with some new topics. Go ahead, guys.
All right. So in regards to the transition from the whales, you said that sometimes I hear you say that fossils are circumstantial evidence. Note that these fossils have been predicted by the theory, and they're necessary for the theory, obviously. You can't look at this transition again in isolation. I think most creationists look at this transition from bland to see in isolation. It's not the only case of it. You have it with saurinians, um, that's manatees and dugongs. You have it with mosasaurs, plesiosaurs, and there are many other aquatic tetrapods that do all show the same transition. So it's very peculiar that we keep finding these transitions if evolution is not true. Um, right. So again, not to look at it in isolation. Secondly, the idea that fossilized life forms or the direct ancestor of anything else is an outdated view. It's I forgot the name of the autogenic view that evolution has this kind of, it has a goal in mind, like the march of progress, where you see a little monkey going up into a man. That's not how evolution works. It's a branching pattern. What else? There was something Standing for Truth said, and an argument he makes that I would like to address now as we're on the transitional forms. In connection with saying that transitional forms are circumstantial evidence, he would say that, you know, we can line up a bicycle and then a tricycle and then whatever next, and then show the same kind of evolutionary progression. There's a difference between design things and living things, being that you can make design things with things we know design without the transition. For example, to go from a bicycle to a tricycle, you would need to change the frame, and you would need to get an additional wheel, obviously, and you would need to show the transition of that actually happening. That doesn't happen in design things. There's no need for a transition. You can just build a tricycle. You don't need to build a transition from a bicycle to a tricycle. So there's actually no transition there. However, let's say to do with birds, for example, any feature you have, you need to show where the bones have maybe meld together or were reduced over time. That's shown in evolution. So that's how we know, for example, living things evolve and design things don't. For example, with cars, he brings up cars, for example. With cars, you can design a car with the engine at the back, and then you can design one with the engine at the front without no transition from the engine going to the front. You don't need that. In evolution, if you need to change a feature like that, you need to show how this trait moved from its, one position to the next. I've seen people use cell phones. They use all these things. For example, you can move the charging port to a cell phone. That would be like the mouth of the animal from the top of the phone to the bottom of the phone. So that would be akin to moving the mouth of the organism from the mouth, from the face to the, where the anus is, without any transition. That doesn't happen in living things. You can do that in design things. You can just change things around, and so on. But in evolution, for every structure you change, you need to show where it changes, and that is exactly what happens. So that's how I know living things. These fossils are not quote unquote circumstantial evidence, and in fact actual evidence that depicts an actual evolutionary lineage.
Okay, I appreciate that conclusion there. Emotionally stunted emoticon. Lots of things that I'd say to that, of course, but we'll save that for our next discussion. We're going for over 2 hours. Lots of fun, lots of things we discussed. We will, I guess, Taylor, if you want to make it short and sweet, what are your concluding thoughts there? Go ahead.
Yeah, starting with the whales. As for you mentioned something about Ambulocetus having crocodile-like features, and aside from the fact that it has the same basic form that even Basilosaurus has, and most of the protocoetids have that same basic form in their skull, they all have the same bone. Like I forget what it's called, but it's a piece of bone at the back of their neck, and that is only found in modern whales and only in this fossil series. So if it was part of the crocodile lineage, we would expect to see at least some crocodiles with that feature, but we only see it in aquatic mammals and Pakicetus. And really all the transitional form research, phylogenetics is it's based on phenotype, and that's what you guys base your supposed kinds on. And it's just that with transitional forms, these phenotypes are shown to overlap. So a general change in body plan is possible. So even assuming like some form of genetic entropy, like I would like to know, what would it take for you guys to call something a new kind? Like if we're all just, the human race is now just boneless, cancer-ridden sacks in wheelchairs, depending on technology, in like 100 years or so, would I feel like this would be a new kind of population, even though it is evolving towards dysfunction through loss. But even assuming a perfect original organism, we could have already gotten to this point through loss of features, or through just modification of features and loss of features. A couple more examples before I wrap it up. Just on the topic of how phenotypes overlap and there is plasticity in these phenotypes. Suppose, just I'm trying to get to some goalposts, but of course we'll talk about this next week. Like, what about if an otter, suppose an otter gets bigger, so it's a giant otter, it loses its hair, it loses its legs, its back legs get extremely small, its front legs get stiffer and shorter. Would this be like a new kind of animal, a new kind of population? And all these changes are possible and have been acknowledged by the creationist side. So I still have yet to really understand what it is that they think limits those kinds of changes that have been shown to be possible from accumulating. And with the last example to kind of tie it in with Stunted's examples with dinosaurs and birds. For example, if there was a theropod that was born with fused fingers, this ties back in to what we were discussing earlier. This fused finger deformity in a two-legged dinosaur, it may be detrimental, and perhaps it did spread through the population. But the thing about evolution is it can repurpose existing material. So it's not like a computing error. It's not like the cell glitches out and can't do it anymore unless there's serious damage to the DNA and replicators. Otherwise, it can just replicate whatever proteins that it needs, or regulate anything that it needs to. So if there was a dinosaur population with fused fingers, and later it also got more feathers, which we know dinosaurs had feathers, and we know a creature can get more or less fur or feathers, would this be a new kind? What if they developed smaller body sizes and lighter frames? So this is what I'm interested in discussing. And thanks for having us on, and it's been fun.
Okay, thanks for your conclusion there, Snake. A lot of stuff we will definitely touch on in future discussions. Matt, I hand it off to you. Conclusion, thoughts on the discussion, topics brought up, and things you felt might have been left unaddressed. Go ahead there, brother.
Okay. Thanks, man. Well, I guess, evolution is all about biology and genetics. So I would say, let's look, for example, real quick at something called the beta globin cluster gene. This is a locus gene cluster. It's comprised of 5 different genes, and they're responsible for the creation of body parts, roughly half of the oxygen transport of hemoglobin, for example. So in order for these genes to cluster, they basically they work in conjunction with each other, is what I'm trying to say. So basically, the epsilon gene flips on in the embryonic stage for 8 weeks, then it turns off, and boom, we get the gamma G kicks on, and then gamma A for the remainder of the pregnancy, and then those turn off, and then the last one turns on, which is the delta and the beta genes. So these are amazing because they all work in order and in conjunction. They turn off, and then the next one turns on. It's found down the chromosome 7. So like, let's say you were to take your hand and turn it around and face to your face, and you were to say that the epsilon gene is your thumb. Well, they work just like that. They go down your hand. So basically, any mutation that can occur or alters, or even if you alter these without mutation, let's say that you alter any one of these genes, well, it causes complete havoc in the system. You'll never be born right whatsoever. So what's amazing is that these same gene clusters are identical in every organism, yet they work to build the entirely different things. If these beta globin genes are, they're so amazing, then it's just fascinating to me that these slight different functions, but yet they work in tandem to all do the same thing. These genes are needed for multiple copies. So it would be a design gene, which actually answers your question, Snake, because you need those things. Nothing can work without them. So think about this. How does a similar gene with similar functions progress you from a primitive bacteria life to more advanced life? You don't need different genes with different functions. Don't you need different genes with different functions? That's the whole point, right? How does having a similar gene from bacteria to all life on Earth and humans, especially since duplication genes are often silent? Duplication genes don't even really occur. They've actually found that there's 0.01% duplication errors per million years if you look at the research. So there's just not enough time. There's not enough time for that at all. So what would it take to show a new kind? I don't know. For us, there's a couple things. Probably a sea lion, for example. Supposedly, they move from a land mammal into the ocean or the water, right? So they contain all the genetic material to move back, right? So why don't we easily see that? Why don't they just take them, put them back, and restrict them from water and watch every gene convert to what it used to do? It's because that's not really applicable. Every gene inside their body would have to change its function. Like 90% of every gene would have to change inside of it. And that's not realistic biologically. So I guess if you were saying if they lost hair and they lost their tail, well, that's still in the family level. So I guess that would qualify as I guess that would qualify as what a kind is. But we can talk more about that next week. Anyway, I went too long. I'm going on too long. Sorry.
No, I think that was good. Emotion and Snake gave a decently long conclusion there, and Matt, your conclusion was good as well. I think if I were to give a tiny conclusion, I did talk a little more, so I want to keep it fair. I would say that we talked about junk DNA, non-coding and coding. I would say I think it's clear that the junk DNA era has been completely overturned and is no longer a valid form of evidence for evolutionists. I think it's easy to conclude based on the data that far more than just 15% or 25% of our genome is functional, based on many different roles that we discussed. I think it's clear that genetic change is actually down, not up. We're therefore devolving due to this mutation accumulation, and most importantly, like information in our genomes, at the end of the day, it can arise through mutations, natural selection. As we know and kind of touched on earlier, there exists multiple overlapping codes in our DNA, in our information systems. And all you have to do is just picture receiving an email and finding that it has 3 totally different messages, where you get one message when read normally, one evident message when read in reverse, and one when reading every other letter. This indicates data compression at the highest level, which extends far beyond any computer program ever written by man. I think that screams out design, a creator, and the fact that these mutations, the mutation accumulation that we talked a lot about tonight, only makes the problem worse for evolution, because our information systems, our DNA is so much more complex and packed with information than was ever thought. There's a few things that Emotion brought up and Snake as well, that we didn't really get to touch on in their closings. That would technically be my closing. Guys, thanks so much. We'll definitely touch on those things next time. Good conversation. Neff, sorry you came in a little late there. Definitely get you in for our next hangout and discussion. But yeah, thanks a lot, guys. Standing for Truth is out.